Welcome back to this tutorial series on Pandas. In this video, we will go over some more advanced features of Pandas, like merging, reshaping, and plotting with SQL. Let's dive right in and start with merging and joining data frames. First of all, we will work again with this marks data frame. And the first function we want to take a look at is concatenating, or the concatenating or the concat function. And in order to use it, we will need a second data frame, which I've prepared. Or Jenny. And now we can concatenate these two data frames along the 0 axis, i.e. stitching the second one underneath the first one by using the concat function, which takes a list of data frames to concatenate as its input, and optionally the index too. But as we, or the axis, I wanted to say. Yes. So we just put Jenny underneath that. And if we wanted to stitch these objects together besides each other, i.e. concatenating on axis 1, we can just specify this as a keyword again. And in this case, the second data frame only has 2 rows, and the remaining ones are filled with NaN values again. Another helpful feature of the concat function is the keys keyword. Tongue breaker, that is. With this, we can still differentiate between the two data frames after concatenating them. And the same result can be achieved using a dictionary with the keys being the labels, the values being the data frames as the input, but I will not dive as deep into that. As you can see, we just have the labels right here. The next function we will take a look at is the merge function. And in order to see what it does, we will create 2 data frames of different sizes. Here 1 and div2. As you can see, they both differ in size. And the merge function has some more nuanced options, but delving deep into each of them is out of scope for this short tutorial series. I will only give you this one example of this function and leave the rest to you to find out for yourself if needed. With this function, we can specify which data frames we want to merge, on which column, how to do it, and lots more. I've left the indicator right here. Like this example. Right. Next up is join. And join is a convenient method for combining the columns of 2 potentially differently indexed data frames into a single result data frame. Here's a basic example. I'll show both of these. As you can see, they share some indices, K0 and K2, but K3 is only on the right, and here one only on the left. Now we can just join those. And as you can see, we have a resulting data frame with 3 rows and 4 columns with some NaN values, as C and D aren't specified with K1 in the right one, yes. The next section we will address is reshaping with pivot tables and stacking. A pivot table is basically a grouped data frame with 1 or more variables used as the index. Considering the definition on Wikipedia, this really should be called a contingency table, but let's not get ahead of ourselves. Just take a look at it. I've created a data frame for this illustration, and it has 4 different columns, namely value, variable 1, variable 2, and date. And a better representation of this data would be where the columns are the unique values and an index of dates identifies individual observations. To reshape the data into this format, we can use the pivot method and specify the columns as the intended parts of the output. Results in this rather nice looking data frame. It's a little bit more organized. And we can also create a multi-index table just by providing a list to the index keyword like this. And as you can see, missing values will again be filled as NaNs by default. Yeah, here we have a list of indices. The more versatile function in this regard is the pivot table function, as it allows for aggregating as well. And we can achieve the same result as in our first call of the pivot method by using this method in basically the same way. Yeah, as you can see, these are the same. But as I said, we can include one or more aggregating functions in the function call and calculate, for example, the sum and mean of each value. In this case, yeah, both functions return the same values, but it's just a demonstration. Closely related to the pivot function are the stack and unstack methods. To summarize, stacking means to pivot a level of the column labels, returning a data frame with an index with a new innermost level of row labels, and unstacking refers to the inverse operation. Let's look at it in practice. Data frame, and if we now stack this data frame, we get a new representation of the data in which the column labels have become secondary indices. Here the columns are our secondary indices. And if we unstack after this operation, we should be left with the original data frame. All right, the last topic of this tutorial series in Pandas is, strictly speaking, not about Pandas, but a different package that works very well with Pandas. We're going to make beautiful plots with only a few simple instructions. As with the other topics in this video, I will only be giving you a quick overview of what's possible. First of all, we are going to import the package and create a simple line plot. The keyword U refers to which column label should be used to differentiate values. In this case, we have the different parameters of variable 1, namely A, B, C, and D. And Seaborn also has a bunch of different plots built in, like the bar plot, which looks, I think, a lot nicer than the built-in functions. The Pandas, the pair plot, or even the violin plot, for which I will use another data set. So this, yeah, I think that is a pretty beautiful plot. All right. That's it for this short tutorial series on Pandas. And I hope you've picked up some useful information and are ready to try using some of these functions on your own.